Hello everyone, today we are going to talk about the Varactor diode principles and applications. So, when we consider about the definition of a Varactor diode is a type of diode designed to work in the reverse bias region. So, when you can see that here, there is a junction between anode and cathode. This junction have a two parallel plates. This parallel plates will act as a capacitor. So the use of this type of diodes basically for the tuner circuit or frequency modulation or any other RF designs we can use it. The side of the diode will represent as a anode and the side of the diode will represent as a cathode. When you are applying a positive on the anode and negative on the cathode, this will act as a normal diode. When the case of a reverse biasing, when you are applying a positive in the cathode and negative in the anode, so there is a reverse wire. So in the case of PN junction diode, normally in the reverse bias, it will not conduct in there. It will act as a uh, high resistance on it, so it will not conduct in that region. When you are applying a reverse voltage on the anode, there is a capacitance will form in between these two parallel plates. This property we can use as a uh, for the modulation purpose and a tuner circuit. Basically, tuner circuit is an example for using a Varactor diode. So the case is if here I'm explaining about that how this reverse voltage is varying with respect to the capacitance. So the junction capacitance will changes based on the reverse bias voltage. So you can say that junction capacitance C is equal to epsilon A divided by T. So this epsilon represents the permittivity of the material and A represents the area and D represents the junction width. So this D or some equations are so that it mentioned that W, D or W, so it represents the width of the junction. If the width is increasing, capacitance will decrease. So this is an inversely proportional. So we know the condition that if reverse bias increases, the junction width will increases. When junction width is increases, capacitance will goes opposite. So you have to get a higher capacitance, you have to keep the junction width minimum. Okay, so this is the representation, the graphical representation. So here you can see that if the junction capacitance is higher when your reverse bias voltage is in near to zero minimum, if the reverse voltage is increasing, the junction capacitance also decreasing. So it is inversely proportional. So to increase the capacitance, you can use as a minimum voltage applying in the reverse bias voltage. And what is the advantage of a Varactor diode? Basically, it is less noise compared to other diode and less costly and more reliable. And Varactor diode small in size and less in weight. And diode consider Varactor diode we are using as a tuning circuit. Here there are two Varactor diodes. We mentioned that D1 and D2, and there is a positive supply applied on the in this cathode. So the cathode, when you're applying a positive supply voltage, it will consider as a this is in the reverse bias voltage. If you can vary the uh, voltage here applied here, that will vary the capacitance between D1 and D2. So that consideration we are talking in the frequency consideration, F0 is equal to 1 by 2 pi root of LCT. Whenever the frequency, if you want a more frequency, you have to change the capacitance here. So the capacitance and the inductor values variations will vary the frequency here. Here the the L is considered as the load and only we can vary here. Whenever you are varying the capacitance based on that, the capacitance value will vary. Based on that, your frequency will vary. So here we have a two capacitance we mentioned D1 and D2. So C of T is equal to C1 C2 divided by C1 plus C2. So this is the a basic application of a Varactor diode based circuit. We call this a tuning circuit. How we are tuning the circuit based on the frequency variations you are applying in the circuit.